Hi everyone. Today is November 11th, Friday, and today we have a quiz. So the quiz covers from 5.1 to 5.4. Okay, everybody? Are you able to see the quiz in Blackboard? Okay. So last time we talked about the graph of sine function and cosine function. So let me summarize with you. Okay, so yeah, you can find a piece of paper, write it down. All right, so sine and cosine, they're like wave. Okay, so sine and cosine like wave. And for the sine function, we start with the origin, 0, 0. Okay, so this is the x-axis, this is the y-axis, and this is a 0. The sine function and cosine function, they're like wave. And the sine start with 0, 0. So you start with 0, 0, and then you go up and down like that. Okay, everybody? So this is a sine function. And the period is what? The period is 2 pi. Right, everybody? The period is 2 pi. And then, therefore, in the middle here is pi over 2, right? And here the middle is 3 pi over 2. Okay, everybody? So these are the 5 important points, or I say these are the 5 key points you want to draw when you're asked to graph a sine function. Okay, you draw those 5 points and then you just connect them smoothly. Okay, everybody? Yes, and some problems in the exam will ask you to find the sine value of some angle. Okay, what we used to do is you look at the unit circle and figure out what quadrant it lies in, and then figure out the reference angle, and then the sine of that value equals plus or minus sine of the reference angle. So this is what we were doing. But from now on, my suggestion is look at this sine graph. Okay, we know quadrant 1 is from 0 to pi over 2. Right, everybody? And quadrant 2 is from 0 to pi. Oh, sorry, pi over 2 to pi. Yes, everybody? And quadrant 3 is from pi to 3 pi over 2. Yes, everybody? And quadrant 4 is from 3 pi over 2 to 2 pi. So now you can look at this graph. I tell you. Okay, quadrant 3. The sign is positive or negative? Negative. Yes, everybody? You see, this curve is below the x-axis. That's why it is negative. And how about the special angle value? Remember the special angle value? We have so we have 0, pi over 6, pi over 4, pi over 3, and pi over 2. These are the special angle value, right? And how about the sine? Now from the picture, you know, because it starts with 0, 0, so sine of 0 is 0. And sine of pi over 2 is 1. Right, everybody? Sine of pi over 2 is 1. And then the rest, you remember that rule, square roots of n over 2, and you let n goes from 0, 1, 2, 3, 4. That's why here at pi over 6, sine of pi over 6 is 1/2. And look at this picture. Sine pi over 6. Like here. Do you see sine pi over 6? We get 1/2. Sine pi over 4 is root 2 over 2, which is right here, pi over 4. This is root 2 over 2. Okay? And sine of pi over 3 is root 3 over 3. So you see this number, this is 1/2, this is root 2 over 2, this is root 3 over 3. And you can see those numbers, they are increasing. Okay? So therefore from now on, if I ask you like any angle, like 11 pi over 6, something like that. What's 11 pi over 6? Well, then you think 11 pi over 6. This is like 2 pi minus pi over 6. Because 2 pi is like 12 pi over 6. Right, everybody? Yeah, so this is like 2 pi is 12 pi over 6. Therefore, 11 pi over 6 is 2 pi minus pi over 6. So 2 pi is right here, minus pi over 6. So, this is pi over 6, right? You have pi over 2, and then you cut it into 3 pieces. Then each piece is pi over 6, right? So, therefore, 11 pi over 6. So you kind of divide it into 3 pieces, and this is 11 pi over 6. Then you see, look at this point. It's negative. Yeah, you see, it's negative. So we know sine of 11 pi over 6 is negative. And then you see here, the reference angle. The reference angle, if you have 6 in the denominator, the reference angle will be pi over 6. Okay? So that's why the reference angle is pi over 6. Therefore, that is 1/2. And maybe the graph is not so pretty, but this should be 1/2. Therefore, this is negative 1/2. Is that okay, everybody? So I would say, for me, I love to look at the sine graph and then to figure out the special angle values instead of looking at the unit circles. Because if I ask you like more than 2 pi, if I ask you, okay, how about 7 pi? 7 pi over 2? Wow, then you imagine 7 pi over 2. This is outside of 2 pi, right? So you can like keep going, extend it. 7 pi over 2 is what? 7 over 2. Is it 3.5 pi? Yeah. So, okay. I don't want to erase that. That means this is 4 pi. 3.5 pi is right here. Do you see that number is minus 1? Yes? So look at the sine graph and you can figure that value very quick. Okay, everybody? How about one more example? 5 pi over 4. What is sine 5 pi over 4? Well, 5 pi over 4 is bigger than pi. Do you agree? So bigger than pi here is actually pi plus pi over 4. Yes? Right, everybody? 5 pi over 4 is actually pi plus pi over 4. So pi is right here. You add pi over 4, which is the half of this, right? So this is 5 pi over 4. And therefore, it's negative. You see? It's negative. And then, look at your denominator. Your denominator is 4. So the reference angle, pi over 4, which is root 2 over 2. Okay? Everybody? So this is how to use the sine graph to figure out some special angle values instead of using the unit circle. So what do you feel? Do you like this better than the unit circle, or you're more familiar with the unit circle? then you can keep using these. Up to you. I'm just giving you another way to do it. Okay, but when you draw the sine graph or the cosine graph, look at those 5 key points. That they are what? They are, the 5 key points are 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, and 2 pi, 0. So this is a sine graph. How about cosine? Cosine and sine, they are waves, right? But cosine, you start with 0, 1, and then you go down, up. Period is also 2 pi. Therefore, this is pi over 2, this is 3 pi over 2. So you look at the 5 key points. They are 1, pi over 2, and pi, 3 pi over 2, and the 2 pi. Is that okay, everybody? Yes? Okay, so this is the cosine graph. And then continue. So for the 10 minutes you missed, don't forget to watch the recording and make sure you know it. Okay, so yeah, last time we did the examples. So now let's look at this one. So cosine. Cosine, we start with 1. Okay, start with 1. Look at the cosine graph. The key points, they are 1. And then at pi over 2, we got 0. And then negative 1. And then 0. And then 1. Right, everybody? So those are the 5 key points. So 1, 0, negative 1, 0, 1. Those are the 5 key points. And then you look at this guy. Oh, this is our function. We want to multiply by 3.5. Therefore, 3.5 times 1 is 3.5. And 0 times anything is 0. Negative 1 times 3.5 is negative 3.5. 0 times 3.5 is 0. And 1 times 3.5 is 3.5. So when x equals to 0, we get 3.5. So this is a 3.5. At pi over 2, we get 0. At pi, negative 3.5. Okay. And then at 3 pi over 2, 0. And at 1, pi over 2, sorry, 2 pi is 3.5. 3.5 is right there. And then we connect them smoothly. And we get that. Usually, the problem in the exam will ask you to draw 2 periods. So this is 1 period. And then you kind of shift this a little bit on the left. So that point is right here. Okay. And this point and that point. So you draw it. So far, so good, everybody? You draw 1 period, and then you look at this one. Oh, this point is like that. And then, so this one here, it goes down, and then here it goes down, and then go up, and then go up. So you draw another period. So you have 2 periods in the exams. So far, so good, everybody? Okay, let's look at harder problems. Okay, so this is vertical stretch, right? And horizontal compress, we're gonna change the inner what do you say? Okay, the inputs. Okay, so here instead of x, we have 2x in the inputs. Okay, and usually let's call this be theta. Okay, so this is like sine theta. Right? So theta is 2x. In this case, how do you draw it? because now sine. Always remember those are the 5 key points. The angle. This new angle is 2x, okay? But you call it theta. Now you let theta to be those 5 points. Those 5 points are 0, 2, pi, 3 pi over 2, and 2 pi. Okay, everybody? So that's always the angle, theta. Okay, so if the inner function is not like x, it's like 2x or something else, you always let that be theta. And you start with that theta values. Your theta values always from 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then your sine value, sine of theta, is always 0, 1, 0, minus 1, 0. So these are the 5 key points. Is that okay, everybody? And then you figure out what's the x. So here I got theta is 2x. How do you find x? You both sides divided by 2. Yes, everybody? How do we find x? Both sides divided by 2. Oh! See, my theta is 0. When you divide it by 2, what do you get? 0. Exactly. And then when my theta is pi over 2, well, when you divide it by 2, what do you get? Pi over 4. Okay? And then next number. Pi over 2. Next number. 3 pi over 4. Next number. We have pi. Right? Okay, let me put down the order. First step, you do the theta column. Okay, that's your step 1. Step 2, you do the sine theta column. And then step 3, figure out what's the x. Okay, that's step 3. And then last step, plot the points and connect them smoothly. So now you see, when you plug in the points, you're looking at the x column and the y column. Right, everybody? So 0, 0. So x is 0, y is 0. And then next, we have pi over 4. So pi over 4, you know pi over 4 is half of pi over 2? Yeah? So pi over 4 is half of pi over 2. And y is 1. Okay, y is 1, which is up there. Pi over 4, we get 1. Next point, pi over 2. Do you see we get 0? Yes, everybody? At pi over 2, we get 0. And then 3 pi over 4, we get negative 1. That's down there. And then at pi, we get 0, right? Okay, those are the 5 key points. And then we connect them smoothly. So this is one period of the function. And usually the problem will ask you to draw 2 periods. So you kind of draw another copy here or draw another copy here, up to you. So 2 periods. What do you want? You want to draw the left or draw the right? Which do you prefer? Doesn't matter. Left. Okay. So that's why we will get here, and then put the point here, and then here. Put the point there and connect them smoothly. Bless you. So you get another period. So we have 2 periods. Now, look at the period. The period, see, from here to here, that's 1 period. What's that? That's pi. Yes, the old sine function, the period was 2 pi. But now, this new function, sine 2x, the period is pi. So in general, okay, in general, if you have y equals sine dx or y equals cosine dx, your period will be 2 pi over b. B is the coefficient of x inside. Yes, everybody? Okay, so this is very, very important. Your period is 2 pi over b. Therefore, this problem, our b, see, the coefficient of x is 2. Yes, everybody? So, therefore, we have the period 2 pi over 2, which is pi. So far, so good, everybody? Okay. And then next example, I will leave it as an exercise. And this example, I will leave it as exercise. So, yes. Okay? Because we don't have time to cover all of them. Yes. So, we go to, let's see. Okay. Go to page, okay, translations. Okay. So, we can have like horizontal translations or vertical translations. So horizontal translations like shift to the left or shift to the right. Okay. So do you remember if we have x minus d, we shift to the right d units? Yes. If we have x plus d, then we shift to the left d units. Yes, everybody? So we learned that before. Okay, and this horizontal translation is called the phase shift. And then the expression x minus d, where you plug in the trig function, is called the argument. So argument is like whatever you input the trig functions. Okay, so what do we do if there is a horizontal shift? Okay, let's do page 10, number 4. Okay, so we select some problems to do. The rest, you can do it at home as exercise. Okay, so in general, what do you do? Let me see. Okay, so this table is not so good. Let me. Oh, so, okay. So here, let's draw one more line there. Okay, because this is a common step. What you're gonna do? You put this is the theta. Okay, and then you put this is the sine theta. So your sine, sorry, our function is cosine, okay? So our function is cosine. Then here we put cosine theta. Okay, so this is your page 10, problem 4 on page 10. Okay, so cosine theta, what that means, that's cosine of x minus pi over 3. Okay, so this is how you change your table. So when you ask to draw the graph of trig functions, you don't need to do those translations. Remember what we were doing? Yes. Pi over 2. Pi over x minus pi over 3. That's the problem. Because we call that whatever is sine and cosine to be the angle theta. And then, so this is theta, and then here is the trig function, cosine theta. And then the next step, this is the, what do we want? We minus 2 cosine x minus pi over 3. Okay, so from now on, when you're asked to draw the graph of the trig functions, you draw this table. Okay, the table should have 4 columns. First column is x. Second column, theta. Okay, everybody? Theta is the argument, whatever inside the current function. Can you find it? Page 10, yes. And then the third column is the trig function of theta. And then the last column is the function we're looking for. Okay, so 4 columns on your table. And step 1, you look at the theta column. Okay, so I also write down the steps so you know what's the order. So step 1, fill out the theta column. And for cosine, the special value for cosine, 0, 1, pi over 2, 0, pi, -1, 3 pi over 2, 0, and 2 pi, 1. Okay? Those are the 5 key points of the cosine. Everybody clear? Yes. So, come back. 0, pi over 2, and pi, 3 pi over 2, and 2 pi. So far, so good, everybody? Okay. And then the cosine theta. What's that? What's cosine 0? 1. And then 0. Then -1, 0, 1. Good. So this is the second step. Okay? You always fill out the theta column first, and then the cosine theta column. Because these 5 points are fixed. Yes, everybody? Now, the third step, figure out the x. Figure out the x. So we have theta. See? So theta equals x minus pi over 3. Then what's x? Theta plus pi over 3. Right? So theta is x minus pi over 3. You solve for x. So you add pi over 3 on both sides. Yes, everybody? Okay. Look at here. Theta is 0. What's x? Pi over 3. And then when theta is pi over 2, what's your x? Pi over 2 plus pi over 3 is 5 pi over 6. Yes? And when my theta is pi, what's pi plus pi over 3? 4 pi over 3. Right, everybody? Okay, how about 3 pi over 2 plus pi over 3? So 3 pi over 2 is like 3 times 3, so 9. Is it 9 pi over 6? Plus 1, is it 2 pi over 2 pi over 11 pi over 6? Yes, 11 pi over 6, right, everybody? Next, 2 pi plus pi over 3 is 7 pi over 3? Okay, those are the x values. That's the third step. Fourth step, figure out the y values. Okay, this is the cosine theta. Do you see here what we are doing? Multiply by -1. Yeah? 1 times -1 is 1 times -2 is -2. 0 times -2, 0. -2 times -1, 2. And then 0, then -2. Yes, everybody? So, yeah, this is how you figure out the table. So you don't need to draw the steps of the calculation, and you don't need to do those things. You only need to draw the table, and then figure out the x values and the y values, plus those points on the coordinates, and connect the points smoothly. got you. Okay. So by the way, in the exam, I might not give you this. I might not give you this this picture. Okay, so let's do without the picture. So without the picture in the exam, how you do it? So you draw the x's and then you draw the y-axis. Okay. So this is the x-axis. This is the y-axis. Okay, and you are looking at the x column and the y column. Okay, so pi over 3. Pi over 3. Without, if I don't give you a grid, what do? You know, pi over 3 is, you have pi and then you divide it into 3 pieces. Yes, everybody? So that's pi over 3. When x is pi over 3, we get y is -2. So right here. Yes, everybody? And then when x is 5 pi over 6. You know, 5 pi over 6 is like you divided pi into 6 pieces, and it is right here. So this is 5 pi over 6 right here. And it's 0. Is that okay, everybody? You divided pi into 6 pieces, and then 5 pi over 6 right here. Okay? Next, 4 pi over 3. You know, 4 pi over 3 is like pi plus pi over 3. So, pi plus pi over 3. So here, you cut it into 3 pieces, and then this piece is 4 pi over 3. Yes, everybody? This is 4 pi over 3. And the y is what? 2 right here. Yes. And then 11 pi over 6. Do you think 11 pi over 6 is 2 pi minus pi over 6? Because the 12 pi over 6 is 2 pi. So this is 2 pi minus pi over 6, which is right here. So this is 11 pi over 6 right here. Is that okay, everybody? So this is pi. You divide it into 6 pieces. And then this is 11 pi over 6. And at 11 pi over 6, we get 0. And then finally, 7 pi over 3. Oh, we gotta keep going. Yeah? So that's pi, that's 2 pi, and let's say this is 3 pi. And 7 pi over 3, we cut it into 3 pieces. And this is 7 pi over 3. And we get -2. Okay? So finally, connect them smoothly. So this is the graph of -2 cosine of x minus pi over 3. Is that okay, everybody? And usually the problem will ask you to draw 2 periods. Okay, so then what do? You kind of what happened? Okay, so you kind of measure, oh, this distance. Okay, this distance is like that. So, and then you measure, oh, it's right here. Okay, so put the small point there so it has the same distance. I don't want to erase it. Okay, so put this around the same distance, like here, you put it here, so it's a point. And about the same distance, you are at what? Up there, right? And about the same distance, you're at 0, and about the same distance, you're down there. So then you connect them. So you can draw 2 periods. Okay? So the first period has to be more precise, so you list the point there. For the second period, you kind of roughly estimate and draw it. So this is how you draw it in the exam. So the exam, I won't give you the schedule, the grid. then you can draw it like that. Okay, and then I will also ask you, what's the period? Cosine. The period of cosine x is 2 pi. And then you look at x. What's the coefficient of x? What's the coefficient of x? 1. So therefore, the period is 2 pi over 1, which is 2 pi. So far, so good, everybody? Okay, good. Yes. Let's do a more complicated function. Let's do this one. This is more complicated. Okay. By the way, okay, we finished this problem, but if I want to ask you, how do you transform? Okay, so this is outside of this problem. So you start with cosine x. How do you get to this one? What operation did you do? Well, then you say, first one, what? Shift left or right? Shift right, power 3 units. So then you get y equals cosine x minus pi over 3, right? And then what do? What did the negative do to it? Yeah, we flat over what? Which axis? X-axis, very good. So y equals negative cosine x minus pi over 3. And at the end, what do you do next? Yeah, vertical stretch by a factor of 2. Okay, by a factor of 2. Then you get y equals negative 2 cosine x minus power 3. Okay, so you don't have to do this in the exam. I'm just telling you from this problem, you can know what transformation we do to it. Okay? Yeah. So then, leaving as an exercise, let's do the last problem. Okay, so let me delete that because in the exam you won't have any grade. Okay. So what do you do when you see some problem like this? Draw the table. The table, you have your first column is x. And then your second column is what? Theta. And in this case, theta is 1/2 x minus pi. Yeah, everybody? Whatever the argument. 1/2 x minus pi. And then the trig function, sine theta. Yes, everybody? And then last one. This is what? 4 minus 2. Can I just put 2 sine theta? Then I can write less. Yeah, they mean the same thing. Okay, your theta always goes from what? What are the 5 key points for sine? You start with 0, power, 0 and power 2, and then pi, and then 3 power 2, and then 2 pi. How about your sine values? 0, 1, 0, minus 1, and 0. Yes, so this is first step, this is second step. What's the third step? Find the x. See, theta is 1/2 x minus pi. Well, how do you solve for x? You add pi on both sides, right, everybody? And then you multiply by 2 on both sides. Yes, everybody? So we have x is 2 theta plus 2 pi. That's the x. All right. When we plug in theta is 0, what happens? What's x? What's x? Theta is 0. What's x? 2 pi, exactly. How about when theta is pi over 2? You plug in theta is pi over 2. What do you get? Pi over 2 times 2 is pi, right? Pi plus 2 pi is 3 pi. When you plug in theta is pi, what do you get? When you plug in theta is 4 pi, right, everybody? Yes? We plug in theta is pi here. 2 times pi plus 2 pi is 4 pi. How about we plug in theta is 3 pi over 2? What do we get? 2, 3, 4. What's next? 5. Next. Next. 6. That's why in the exam I won't give you the grades because it depends on the problem. Your grades maybe not long enough. Okay, so I won't give you a grade. And then you just base it on this value to figure it out. Okay, look at this. Bless you. Sine theta is 0. Then you plug in. You get what? 4 minus 2 times 0 is 4. Sine theta is 1. 4 minus 2 times 1 is 2. See? We plug in 0 again. We get what? 4. Yeah? And here, we plug in 0 again. We get 4. Right? Okay, if we plug in minus 1, what do we get? 6. Yes. So you draw the table. Okay? Step 1, figure out the theta values. Step 2, figure out the sine theta values. Step 3, find the x values. Step 4, find the y values. And then once you have the x value and the y values, you're ready to draw the graph. Okay, so we have x, y, 0. Do you see your x go to 6 pi? Okay, so you need at least 6 pi. So, okay, let's say 6 pi is here. The middle one, 3 pi. And then cut it into 3 pieces. This is 2 pi, this is pi. Cut it into 2 pieces, 4 pi and 5 pi. Is that okay, everybody? You draw the graph and then you plot the point as how long you need. You need 6 pi, 3 to 6 pi. And then you cut it over 2 pieces, 3 pieces. You can write that. Okay, look at my x value. My x is 2 pi. Then the y is what? 4. Okay. 4. Then let's say this is 2 and this is 6. So at 2 pi we get 4 right here. Yes, 2 pi, 4. 2 pi, 4. 3 pi, we get 2. So 3 pi, we get 2. 4 pi, we get what? 4. 5 pi, we get 6. 6 pi, we get 4. See? Okay, connect them smoothly. This is a picture. That's 1 period. You need what? You need 2 periods. So we can imagine here. So see, here we will go to 6, and then another one we go to 4. So that's 6, that's 4, and then 2, and then 4. Connect them smoothly. Then you get 2 periods. Right, everybody? And finally, the problem will also ask you, what is the period? For sine, the period is 2 pi, but look at the coefficient of x. What's coefficient of x? 1/2. Can everybody see that? Coefficient of x is 1/2. So divided by 1/2, which is what? 4 pi. Is that okay, everybody? By the way, will this pi change my period? Will this pi change my period? Will this pi change my period? No. Okay? So this pi is like horizontal shift. It does not change the period. Okay? This 1/2 is like horizontal compression. It will change the period. Okay. So yeah, in the exam, these are the work you want to show. Okay? But now I want to ask you more. So can you write down the sequence of transformations? Okay, so I just want to relate to what we learned before. Can you write down the sequence of transformations? First step, your parent function is what? Let me shrink this little bit, make it smaller, so then I can have more space. Okay. Okay, so I want to write down the transformations. So parent function y equals sine x, right, everybody? Step 1, we shift what? Left or right? Right, how many units? Pi units. Then we get y equals sine x minus pi. Next, do you see this 1/2? Okay, so step 2, reflect over the y-axis. But I told you, so that corresponds to when you have a negative sign in front of the x. But if you have a multiple in front of a number in front of the x, you actually have horizontal compression. Okay, so here, this 1/2. Okay, this 1/2 is gonna be horizontal stretch. Okay, if this number is bigger than 1, it's compression. If that number is less than 1, then it's horizontal stretch. So this is horizontal stretch. That's true. And we get y equals sine 1/2 x minus pi. And then what do we do? What happened to this minus sign? Reflect over what? The x-axis, right? So we have a minus sign. And how about the 2? What does the 2 do to it? Vertical stretch. So vertical stretch. And so then we have the 2. Finally, what happened to the 4? Shift up. Yeah, up 4 units. So we have negative 2 sine 1/2 x minus pi plus 4. So these are the transformations. In this exam, in exam 3, yeah, you don't need to do this. Okay? You only need to draw the graph of the transformations. Yes, everybody? Okay. Keep going. This is 6.1. Any questions about 6.1? Are we all good? Okay, so 6.2. Yes. So I hope you can have this picture in your mind. Sine graph, the 5 key points. They are these 5 points. It's like wave, they start with 0. Cosine is wave, but start with 0, 1. Okay, so remember those 5 key points. Okay, so 6.2. The graphs of other trig functions. Alright, first, tangent. Okay, so tangent. How do we get a graph of tangent? Well, imagine tangent is sine over cosine. Right, everybody? Sine over cosine. So, do you still remember our special angle value? So, if x is 0, pi over 6, pi over 4, pi over 3, bless you, pi over 2. What is your sine? 0 and then 1 half and then root 2 over 2 and then root 3 over 2 and then 1, right? Please make sure you can remember those values. Okay, so every day we're learning something new. Cosine, same number, reverse order. Yes, everybody? Same function, same value, reverse order. Okay, now tangent. Tangent, sine over cosine. So you use 0 over 1 is 0 over 1 is 0, yeah? 1 half over root 2, so 1 half over root 3 over 2. The 2 cancel. You get 1 over root 3. Yes, everybody? And then, oh, do you see these two numbers are the same? So when you divide it by it, you get what? This over this, you get 1, right? Because they cancel. It's the same number. Okay, we cancel. And then, this over that, do you see 1 half cancel? We just get root 3. And then 1 over 0, undefined. Yes, everybody? So therefore, at 0, we get 0. Pi over 6, we get 1 over root 3. Pi over 4, 1. Pi over 3, root 3. Pi over 2, undefined. Okay. And then when you plot those, so 0, 0 is here. 1 over root 3, kind of there, okay? And at pi over 4 is at 1. And then root 3, 1.7, something like that. And pi over 2, undefined. Undefined, you can draw vertical line. This is a vertical axis. And do you remember for tangent? The first quadrant, the tangent is positive or negative? The tangent, positive, right? Okay. Second quadrant, tangent is negative, right? The third quadrant, the tangent is positive. The fourth quadrant, the tangent is negative, right? So therefore, you see, this is quadrant 1. And quadrant 2, our tangent value is going to be negative. In quadrant 3, our tangent value is positive. And quadrant 4, the tangent value is negative. So therefore, you end up getting a graph like that. So this is a graph of tangent. Okay? But what do we care? Okay? So what do we care? The points we care, like the sign, you only care about those 5 points. But tangent, what do you care? All right, so what do you care for tangent? You care about 0, 0. Oops. You care about 0, 0. And then you care about pi over 4 is at 1. And then pi over 2, we get a asymptote. And negative pi over 4, we get negative 1. Negative pi over 2, we get vertical asymptote. And then you connect those points smoothly. So this is the tangent x. And And do you see what's the period? What's the difference between pi over 2 and negative pi over 2? Pi, exactly. The period is pi. And therefore, this is pi, and this is 3 pi over 2. You get the periodic functions. Period with pi, you just get a lot of another, like, okay, just draw more. So this is how you draw the tangent. Okay? Care about 5 points. So 0, pi over 4, and pi over 2. Is that clear, everybody? And then the rest, just copy it. Okay, so those are the 5 key points. So you don't need to look at this big table. No, just look at those 5 key points. And also, let's look at the picture. Your domain. Do you see there are a lot of vertical asymptotes? So x cannot be those asymptotes. So therefore, your domain x not equal to, this is pi over 2, and then you can say pi over 2 plus n times pi. Okay? Because it cannot be pi over 2, it cannot be negative pi over 2, it cannot be 3 pi over 2. So there are pi over 2 plus n times pi, where n is an integer. Are you okay with this notation? N is a set of the integer. Yes? That means integer, n is integer. How about range? Your y values. See? Your y values go from minus infinity to positive infinity. Yeah, everybody? Can you see that from the graph? So y value from minus infinity to infinity. Okay, good. Let's look at properties. The period I. Okay? The vertical asymptote. Y pi over 2 plus n times pi. X-intercept. You see? X-intercept at 0, at pi, at 2 pi, at negative pi. So they are n times pi. They are the x-intercepts. The graph has no amplitude. Well, amplitude is, so our picture. Amplitude is this number. Okay? So cosine and sine, the amplitude is 1. Okay? And it's whatever number we multiply. So for our last example, what was our last example that we did? Where's 6.1? Okay. Our last example, what is the amplitude? Yes, here at the bottom. The amplitude is whatever multiplied by the trig function. 2, exactly. So the amplitude is 2. Okay, so this is the amplitude. Is that okay, everybody? Amplitude, yes. So in general, if you have C plus A times sine B times x minus B, or y equals C plus A times cosine B times x minus B, then the amplitude will be the coefficient of the trig function, so this A. And the period will be 2 pi over, this is the coefficient of x, B. Okay, everybody? So amplitude and period, right. Okay, so keep going. How about cotangent? Well, cotangent is 1 over tangent. Therefore, what's the cotangent values? Okay, so cotangent is the same numbers as tangent, but reverse order. So therefore, undefined, root 3, 1, 1 over root 3, and 0. Is that okay, everybody? So therefore, at 0, we get undefined. And then this is root 3, and this 1 over root 3, and 0. So pi over 4 right here is at 1. Pi over 2 is oh, I see. Okay, because that whatever I write down is for 0, pi over 6, pi over 4, and pi over 3, and then pi over 2. Okay, but now the cotangent, the key points are so cotangent. The key point of a pi over 4 is a 1. A pi over 2 is 0. And then, so therefore, this is 0. So it's like that. And then, when we keep going at pi, this is minus 1. At pi, we also have undefined. So at 3 pi over 4, we get negative 1. And then like that. So this is how to draw the cotangent. Okay. And because the period here is also pi, therefore you draw a lot of copy of it. Domain. Do you see the vertical asymptotes? X cannot be 0, x cannot be pi, x cannot be negative pi. So the domain, x cannot be n times pi. Right? That's the domain. How about range? Range is the y values. The y values is from negative infinity to infinity. Exactly. So minus infinity to infinity. Okay, good. So here we have the properties. The period is pi. The graph is discontinuous. So that means there is a vertical asymptote at n times pi, where n is an integer. X-intercept occurs at, see, this is pi over 2. This is 3 pi over 2. Therefore, you can put them in the form of pi over 2 plus n times pi. Yeah, everybody? And this has no amplitude because it goes forever. Amplitude is like a band. Okay, your sine and cosine is bounded between minus 1 and 1. That's the amplitude. But your tangents and cotangents go forever. You don't have amplitude. So no extrema. The cotangent function is an odd function. Right, you see, cotangent function is an odd function. You pick a point here, you rotate 180 degrees, you also get this point. So this is a cotangent is an odd function. Similarly, tangent is also an odd function. Yeah, we forgot to mention. If you start any point here, you rotate 180 degrees about the origin. You just the point is also on the graph. So this is an odd function. Do you remember our sign? Is it odd or even sign? Odd. This is it passes through the 0, 0, right? It's an odd function. Cosine is even. Therefore, if you use a odd function over an even function, you actually get an odd function. Right, everybody? Okay. So from now on, yes, this is the tangent. Now, cotangent. Cotangent. The key points are 0, undefined. And then at pi over 4, you get 1. And pi over 2, you get 0. 3 pi over 4, you get minus 1. And then at pi, you get undefined. So these are the 5 key points. Okay? So from now on, sine, cosine, tangent, cotangent, you remember those 5 key points. Okay? And then let's continue next class. So we learn more and more. Okay. So yes. Yes. Oh, really? I'm not able to look at these.
Is there a science sheet today or did I miss it?
Ah, did I forget to give you the science sheet today? Oh no! Yes.
Everyone gets.
Yeah, yeah. Oh, everybody gets this.
Did you have my exams?
Yes, I do. Yeah. Oh, good job. Did my alarm ring today?
Yeah.
Yes. Oh, I just forget to say. Oh.
Good afternoon.
Good afternoon.